In this problem, we're facing, is there an infinite set S for which the power set P of S is countable? Why? Please take a second to try this out for yourself, wait for hints, and then we'll show you the answer. Now that you've had an attempt at it, some hints are, we should consider all the infinite sets S, and we should consider which of them is perhaps most suitable for this problem, a limiting case. Additionally, we should be trying to think of theorems which will help us prove the countability of sets. And this why is just trying to emphasize the fact that we are trying to use theorems about the countability of sets. With that, take another attempt and see what you can make. Alright, let's proceed in the way suggested by the hints. Namely, if we consider infinite sets S, there are two distinct possibilities. Either S is countable or S is not countable. And next, we'll consider some theorems about the countability of sets, namely Cantor's theorem, which says that for any set S, the power set of that set S has greater cardinality. And we'll note that we're going to use the absolute value bars to denote the cardinality of the set. This is common notation instead of the notation of Gunning, which is this, but both are useful. So, since we have Cantor's theorem that the power set of a set is has cardinality strictly greater than the cardinality of that set itself, then we can immediately eliminate this case, since if S is not countable and the power set has strictly greater cardinality, then it is also not countable. If we consider the other case of a countable set, well, if it's a countable infinite set, then we can just say it's the natural numbers. And we would note that the power set of the natural numbers is equivalent to the real numbers. This is a common result. Alternatively, you can do this without having this fact, but for now we will use this fact that the power set of the natural numbers has the same cardinality as the real numbers. So we will use that. Therefore, we can just say that this is not the case, since we know the real numbers are uncountable. This is a common result. But if not, you can prove it by considering a subset of the real numbers, namely the interval from 0 to 1, and attempt a proof by contradiction by writing out each of the decimal expansions of all the numbers in there. You can show that this is uncountable, and therefore that the real numbers are uncountable, and therefore that the power set of the natural numbers is uncountable. So, since we've eliminated both cases, it cannot be the case that there is an infinite set. And with that, we're done. Thank you.